this is lesson 8.2a, and the topic today is circular function values. Our purpose today is to prep ourselves for graphing a sine function or a cosine function or a tangent function by learning how to find their function values so we can put them on a graph. Okay. The three topics that we're working on today, or the three skills: finding reflections of coordinates that are on the unit circle, finding the 6 trig function values when given coordinates on the unit circle without a calculator, and then finding trig function values of an angle and radians that you wouldn't find on the unit circle using a calculator. But understand that you can always use a calculator to find a function value. Okay? All right. So we have here a picture of a unit circle labeled in theta, this unit S, which is equal to theta, and some coordinates on the unit circle as x and y. And let's talk about what S means. Okay, so let me give you a formula. Here's something that's true. On the unit circle, your radius is 1. Right? 1 unit. Okay, so here's what I know. Theta is equal to the length of S, which is just a certain section of your circumference. It's called an arc length, over your radius. So we can just define that as, with theta being your angle of rotation, S being an arc length, or a portion of your circumference, and R being a radius. So that's true on any circle, regardless of its radius. If I want to find the measure of the angle, I divide the arc length by the radius, and that'll tell me the angle of theta in radians. Okay, so but theta will be, so let's put in radians right here. It will not be in degrees. If it were in degrees, then we would have to consider the circumference in terms of 360 degrees instead of in radians. Okay, now on the unit circle, here's what we know. The radius equals 1. On the unit circle, the radius equals 1. And therefore, this is on the unit circle. The radius is 1. So therefore, we could say that theta is equal to the arc length divided by 1, which is just the arc length. So the central angle is the same as the arc length. They're the same thing when your radius is 1. Okay? So what we're going to do now is take some information we're provided about the basic circular functions, and we are going to learn to use the coordinates on the unit circle to find the sine of theta, the cosine of theta, the tangent of theta, the cosecant, all of the 6 trig functions. However, I really don't like what's happening on this chart, so we're going to make a couple of little changes. So let me zoom in a little bit. Maybe. So you can see a little better what's happening. So we're going to look at this. It says, for a real number S that determines a point, x, y, on the unit circle, and remember that S is the same thing as theta, which is the measure of the angle on the unit circle. Because we're on the unit circle, radius is 1, so theta equals arc length in radians. Here's what we know. On the unit circle, the sine of S is equal to the second coordinate, or your y over 1. But I don't like that. I would really prefer for you to say the sine of theta on the unit circle. Okay, so we're on the unit circle. And by the way, you can put this on your little index card. That's the only thing you're allowed to have on a test without penalty is your index card. Okay, so the sine of theta is equal to y. The sine of theta on your unit circle is equal to y in your x, y definitions. Okay, sine of theta is equal to y. Cosine of S, it says, is the first coordinate, or x. We're going to say cosine of theta is your x coordinate. on the unit circle. Now the rest of these functions, I need to tell you, I don't need to know anything else to find. If I know sine and I know cosine, if I know x and I know y, then I can find my trig function values for tangent, cotangent, secant, and cosecant. So here it's tangent of s is the second coordinate over the first coordinate, or y over x. But I can decompose the tangent of theta into the sine of theta over the cosine of theta. And I really would like you to start thinking of tangent in that relationship or that ratio, sine over cosine. Okay? So sine of theta is y, cosine of theta is x, as long as x is not 0, because that would make a restriction in your denominator. We can't divide by 0. So when I would like you to start thinking of tangent, now that we're going to graphing in terms of sine and cosine, and not in terms of tangent anymore. It's sine over cosine. So start practicing that. Okay, cosecant is 1 over the second coordinate, or 1 over y. But let's think of cosecant in terms of either sine or cosine. Cosecant is the reciprocal of sine, right? So the cosecant of theta, let me get my pen back here. The cosecant of theta is equivalent to 1 over the sine of theta. So we're going to decompose cosecant into terms of sine. I don't want to think about cosecant. I'd rather just think about sine. So that would be 1 over the sine of theta, which is your y coordinate. With one restriction, right? You cannot put a 0 in your denominator, so y cannot equal 0. And sometimes on your unit circle, your y equals 0. So sometimes your cosecant function will be undefined. Secant is your reciprocal of cosine, so that would be 1 over cosine theta. And cosine of theta equals x, so that's 1 over x, with the restriction that x cannot equal 0. And then last we have cotangent. Now cotangent is the reciprocal of tangent, right? Cotangent, and so I could say that cotangent of theta, which is the reciprocal of tangent, tangent being sine over cosine, so cotangent would be, help me out, in terms of sine and cosine, cotangent would be cosine theta over sine theta, which is x over y, as long as we restrict that y cannot equal 0. So on your index card, I would suggest you would write this information, not that information, this information. I feel like I just drew a little sleigh and I should put some reindeers up front. But anyways, there you go, okay? So start thinking when we're on the unit circle, all we need to know are the coordinates. We need to know the angle. Where are we on the unit circle? What's our angle of rotation? And what's my x coordinate and what's my corresponding y coordinate? So I can find the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. Okay, so let's do a couple little practices with just some reflections so that you understand once you know what some value is in quadrant 1, you can find its values in quadrants 2, 3, and 4. They're just reflections. Okay, so remember in quadrant 1, your x and y are positive, right? And in quadrant 2, x is negative, y is positive. In quadrant 3, negative and negative. Maybe he's going to let me write that. And then positive and negative. So just remember, once I put a point of coordinates in quadrant 1 and I want to reflect them, all I have to do is change the signs according to what quadrant I'm in. Excuse me. Okay, so we're on the unit circle, which me in the instructions it says they're on the unit circle. Each of the following points lies on the unit circle. So that means our radius is 1. Okay, so we're looking at the coordinates 3/5 and 4/5. And let's already think of these in terms of this is my cosine and this is my sine. Because my cosine is x and my sine is y. You know, cosine and sine alphabetically C comes before s, just like x comes before y, so that'll help you remember which one's which. Okay, so let's graph 3/5 and 4/5. Well, in the unit circle, this is 1, the coordinate 1, 0. And up here, this is the coordinate 0, 1, because our radius is 1. So if I want to go 3/5 of the way along the x-axis, I guess I would just break up the x-axis into fifths, right? So this would be 3/5 here. And then if I break the y-axis up, I would also break it up into fifths. And this would be 4/5 here. So 3/5, 4/5 would be right there. So our coordinates here are 3/5 and 4/5. So we have that drawn. And so now what we want to do is the instructions say to reflect it across the x-axis. So that means I want to pop it over the x-axis down here, right? So what I'll do is just connect, and there it is. So now, has my x value changed or is it still positive? My x value? It's still positive because I crossed the x-axis, not the y-axis. So my x-axis is staying the same, but my y is jumping from positive to negative. And we'll go ahead and just take that negative y-axis and type in our, tack in our fifths. 1/5, 2/5, 3/5, 4/5. Okay, so we've reflected it across the y-axis. So you can see those coordinates are the same, but you're in quadrant 4, so your sign is negative and your cosine is positive. And remember, A smart trig class? Remember that's supposed to be true? Okay. All right, so our sine is positive 3/5, our cosine is negative 4/5. Let's go across the y-axis. Here I am. So I'm going to break that up into fifths. So this would be 3/5 here. So our coordinates would be negative 3/5, positive 4/5. It's not a really difficult concept, I don't think, to grab. I feel like I'm already boring you to death. Okay, so here, notice that this is my cosine is negative and my sine is positive. That's supposed to be true. Smart trig class, remember that. Okay, then lastly we have to go reflect across the origin. So we're going this way. So now where am I? In quadrant 3 at negative 3/5, negative 4/5. So you see that those values are the same as we reflect, okay? So here's what we're finding out here, that this measure for this angle will be the same as this angle here. So they're the same triangles basically. One's just in quadrant 1 and one's in quadrant 2. Or that's that measure down there. Or this is that measure down there. And those are just your reference angles. So the reference angles are all the same measure. It's just where did you plot that angle so that you know which sign to assign your cosine and sign to assign your sine. Okay? All right, so there's that. Questions? All right, let's go to this one then. Square root of 2 over 2, square root of 2 over 2. So first of all, that means that, isn't that on a 45, 45, 90? When my cosine and my sine are the same, right? So that would be this point right here that would cut that 90-degree angle in half. Definitely have to have the same x as the same y. That'll give us a 45-degree angle, or pi over 4 if we're in radians. So this would be this point right here, our square root of 2 over 2, square root of 2 over 2. And let's move a little bit faster now. So that's that measure there and this measure here. And if you were to plug the square root of 2 over 2 into your calculator and give you an approximation, it will tell you that it's 0.7071. Okay? So when you're graphing things, it's not really useful to know where's this, you can't really figure out where is the square root of 2 over 2 when I'm trying to graph that on the x-axis. So if you can convert it to a decimal, then you can, go about 0.7 over and put your point and you're good to go. Okay, so let's reflect that down here. What are my coordinates down here? Half square root of 2. Half square root of 2. Or square root of 2 over 2. Okay, if we go across the x, across the y, then our x coordinate will switch signs, but our y coordinate is still positive. And then if we reflect across the origin, both will be negative. And there you go, reflections. Okay, and this is remember this is pi over 4, or 45 degrees. So these all are reference angles of 45 or pi over 4. we're talking about the reference angles. Remember I told you they make a little bow tie. Okay. All right. Last one. Bring this into the picture a little more. So we have the coordinates 1/2, which I think is easy to find, right? We can just go about halfway from 0 to 1. And then we can just go up and put a point. And that would give us this measure up here, which would be the square root of 3 over 2. And here's your measure 1/2. All right? And so there's those coordinates there. Can anybody tell me what angle that is? 60 degrees, or in radians? 180 divided by 6 is 60, right? What's pi divided? No, sorry. 180 divided by 60 is 3, right? So pi divided by 3 is pi over 3, pi thirds. Okay, so that's pi over 3. Then we reflect that down here. That would be 1/2 negative square root of 3 over 2. I think you get it. So I don't want to spend a lot of time. This is just your reference angles for 60 degrees, or your pi over 3 reference angles in each quadrant. Get a negative on there. Negative 1/2 square root of 3 over 2. And also, just so you know, for reference, the square root of 3 over 2 is approximately 0.866. Okay? Got it? So those are your values. So that's reflections. It's just about what quadrant you're in. Okay? All right, let's go to the next page, or on to the other side. And we're going to talk about these questions here, and I'm going to zoom in a little bit. Now, we're going to continue to work on the unit circle, so have your unit circle handy. And we're really going to start focusing on decomposing these values into sine and cosine values, so that we can just use the coordinates on your unit circle. All of these angles are on your unit circle in some form. And so we can use your x coordinates and your y coordinates to find these values. I would like to change d from cosine to secant. That way you have an example for every different trig function, all 6 of them, so that you know what to do. Okay? So we're going to start with the tangent of pi over 3. First thing I'd like you to do is decompose tangent into terms of sine and cosine. Remember, I don't want you to think in tangent. I want you to think in sine and cosine. So what is tangent equal to in terms of sine and cosine? Tangent is sine of pi over 3 over cosine of pi over 3. Again, I want you to think of tangent in terms of sine and cosine. So we're going to deconstruct tangent into terms of sine and cosine. And yes, that's your x coordinate, no, your y coordinate over your x coordinate. So remember, this is cosine and this is sine. Okay, this is your x, this is your y. Oops, didn't mean to do that. Let me bring it back. This is your x and your y. Okay, so let's go to pi over 3. Which is right here, 60 degrees, pi over 3. Learn that the over 3s are 60 degree reference angles. The pi over 3s are 60 degrees. Okay? The pi over 3s are 60 degrees. Say it to yourself, the pi over 3s are 60 degrees. Okay. So what are our coordinates here at pi over 3? Look at your unit circle. 60 degrees, pi over 3. What are our coordinates? 1/2. We just did this one. Pi over 3 is 1/2 square root of 3 over 2. Those are the coordinates on our unit circle. Remember that this is my cosine, this is my sine. You following me? Okay, I'm kind of writing big, so I'm going to write my answer down here. So, let's do that. What's the sine of pi over 3? Square root of 3 over 2. Cosine is 1 over 2. Let's simplify that. Complex fraction, but it's pretty easy to simplify, right? What can I do with my 2's since they're the same denominators? Cancel them, right? Keep change flip in your head. They'll cross cancel. So simplify that. That's the square root of 3. Okay? So I'm going to pause the video while you write this down on your yellow sheet. Go to the tangent of pi over 3 and write the square root of 3.